So I hate to do this to you, but I'm going to take the hard one, okay? Vertex form is really good for finding the vertex, okay?
Oh, yeah.
So I'm going to help you all out. I know you're worried about that one, so I took it off your plate. Which one's good for finding the x-intercept, Spencer?
The x-intercept?
Yeah. What, the second one? What's that one called? Factored form, okay? So just for fun, this one, the vertex is easy to find from vertex form. It's 2, -1, right? Everybody good with that? Yeah. Let's get these x-intercepts from factored form then. What are they? 3 and 1, okay? And the y-intercept's easiest from standard form. What is it? Yeah, 0, 3. Let's go. There's the 3. There's the 3 and the 1. And there's the 2, -1. It's all right there. How cool is it? Like once you know things, you can just look at it and be like, pop, 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 pop. And you know why it's that. Isn't that cool that you know why it's that too a little bit? Like we moved things around on grass. We saw how it changed on Desmos. I think it's super cool. Which means it is cool because, you know. So here's what we're doing next. We are going to start graphing things that are in vertex form. And here's all you need to graph it. I already graphed the vertex here. So both of these equations, let's look. The vertex is, this -4 tells me what? No, right 4. This 10 tells me up 10. Okay, so I got the same vertex here, 4, 10. You guys seeing that? Okay, so without even drawing these, what are things you know about them just looking at these? What's one thing you know, Micah?
I know their position on the graph, and then I can also know the x-intercept by, like, basically finding it. Or
I think the x-intercepts are going to be a challenge from vertex form. I'm saying, like, let's just, there's 2 more things we should just be able to look at these and know. Ellie.
It opens down.
Which one?
The first one.
P of x opens down. How do you know that? The negative in front is going to give me a negative a term. Bob, what else do we know? I don't think we know that.
No, I think we do because wait, my bad.
Okay, what else do we know just looking at the second one before we even try to graph this one? What do we know about it, Hadley? It opens up. How do you know that?
Because 1/2 is positive.
Because it's got positive. What else does that 1/2 tell us? It tells us one more thing, like a general thing. It's going to be wider, right? Because it's going to grow more slowly. So we know all these things before we do anything else. Now, one thing I'm going to point out, and you don't get to use this point, is you guys know how we've talked about this invisible line right here? Called the axis of symmetry. Okay, so if there's a 0, -6 point, there has to be 8, -6 point too, right? Would you agree? Okay, so here's what you're tasked with doing. I want you to find another point that isn't one of these points. Okay, put it on there and graph this parabola. Let's go. 3, 2, 1. Eyes up here. Mouths closed, please. Oh, dang. I lost the thing I drew. Okay, I'm back. So, if I got 0, -6, we talked about how we have to have 0, 8 as well, right? Because of the symmetry right here. Okay? So, if we just find one more point, we actually know how many? 2. So, I'm going to try. I was like, hey, you know, I always want you to try your hardest. I'm going to pick a really hard number to put in there. 1. Okay. This is actually a case where doing something easy is like the right move, actually, okay? We were talking about that back there. So because of the order of operations, you could just put this in your calculator if you want, but -3 squared is 9. And I negative that because the negative in front, that's -9. Plus 10 is 1 plus 10 is -3 times -3 is 9. It's -9 because of this. -9 plus 10 is 1. So, if I have 0.11, I also have to have 0.71 because of my symmetry, right? Let's look at putting a 2 in there. Did anybody put a 2 in there?
I did.
Yeah, let's check that out. So I put a 2 in there. Okay. -2 squared is 4. Negative that. -4 plus 10. 6. So I need to have 0.26 as well. If I have 0.26, I know I have 0.66. And with a lot of these points, guys, look how much easier it is to draw a real nice parabola.
That's what I'm talking about.
I made it pointier than I'd like to and maybe a little squiggly, but that's what's up. Okay. So I'm going to give you a second to go now and do the same thing with Q of X. I want you to find 2 other points, though. By 2 other points, I actually mean 4. I want you to find a point, use your axis of symmetry, find a point, use your axis of symmetry. Okay, let's go. Let's do Q of X now. Guys, I didn't realize how bad this parabola looks until I took a step back, but it's good. You got the idea. Look at my parabola. It's all janky, but it's good. Janky parabolas have their place in this world, too. What's the input that we're using? So, you put in 2?
Yeah.
Okay. I'm inputting 2. I'm going to do 2 minus 4 squared plus 10. Okay. So, order of operations. 2 minus 4. Negative 2. Square it. 4. Half that.
2.
Plus 10.
12.
So 212 is one of my points. If 212 is my point, guess what? 612 is also a point. I got the same vertex here. Oh, it looks like a sad face right now. Okay, let's do 1. 1/2 of 1. Oh, man. I don't know if I can do this. Okay, I'll try my best. 1 minus 4. Negative 3. Square it. 9. Half that.
4.5.
Plus 10.
14.5.
Yeah, that's not the nicest one to do, but it's okay. Stella, you messing with me? 14.5 is like right here. Oh, that's not Stella. That was Willa. And then 1, 2, 3, 4, 5, 6. So then you can use your symmetry. So we actually only found 2 points, but we know 4 of them. Anybody put 0 in?
Yeah.
That would have been a nice one too, but.
Yeah, but that goes to 26, and that's not.
No, it's 18.
Oh, where's this one going to cross X?
Never.
Never. There's no X intercepts for this. Okay.
Not X, but Y is crossing.
It crosses the Y. Yeah. They're always going to cross the Y.
Put in 0.
Do you guys understand that they'll always cross the y-axis if there is a parabola? Because it goes infinitely left and right every time, right? Okay. Can I put in 0? Okay. Cube 0 equals 1/2. 0 minus 4 squared plus 10. So, negative 4 squared. 16. Half that. 8 plus 10.
18.
Oh, you could have put that on there. Oh, look it. I kind of did it even without trying to do it. Kind of. If you make your dots big enough, you can hit lots of lines. Okay. Everybody good on that? Yeah. Was there actually anything new there? No. So let's review how we use things we already knew to do this. From yesterday, we knew how to find the vertex from moving that vertex left, right, up, down, right? And then we have known, like forever, in a function, we could put x in and get y out. How many tables did you guys do when you did constant proportionality last year? Like 3,200 at least. Like over and over, right? You already know it, right? Not a new concept. We still have 2 variables, x and y. You'll have fun later in life when you get the z variable too, okay? 3rd variable. 3 dimensions, Bob. You get to look forward to that. You do it in Innovation Lab, yeah, for 3D printing. You are going to get a set of cards. Your set of cards have a graph and an equation. It is your job to match your graph and equation, and then record your match on the back of your paper. You only need to record 4 of them. I didn't want to kill another tree. So I could get it one sheet, there's only room for 4. So just record 4, but you got to match all of them. So here are our first 2 matches, f of x and g of x, and we're going to point out why they match. First of all, this tells me it opens which way? Up, okay. And then this tells me my vertex is 1 to the right, and this one tells me 4 up. 1 right and 4 up. Remember, the reason this is 1 right is because that would need to be 1 to reestablish 0, 0 from x squared, right? It's kind of like we got x squared as a base, and the minus 1 has to send us right 1 with the vertex because x would need to be 1 to re-zero that out, okay? That's kind of the reason why. I know we wrote down that equation about like the opposite thing and stuff, but... Okay, what about this tells us that it opens down for g of x? The negative, okay. Right there, opens down. What's my vertex? 4, 1. 4 right to re-zero out. There's my vertex. Cool. Any questions on F or G? Okay. We've got H of x and P of x next. What tells me that H of x opens up? It's positive. This sends me which way? Left 1,
Down 4.
down 4. Yep. Okay, over here, this says down. This one sends me 1 left, down 4. So notice same vertex, right? It's kind of cool. And Q and R. This says points. Which way?
Right.
Up. The 2 means up. Yeah, but this one right here, Finn, that means 4 right, 1 up. Now, compared to this one, the 2 means that this one should be what? Yeah, well, narrower or wider? Narrower. It's going to get bigger quicker. It's tough because narrow means small usually, right, Finn? Right? So if it's narrow, it's getting bigger quicker because of that times 2. Over here, this says point up, 4 left, down 1. Cool. Vertex form is intended to have the vertex be easy. Okay. Yeah, Micah.
Will we ever learn how to get vertex form, or no? Will it just always be there for us?
No, you could definitely learn to do it. It's kind of nice actually. Like let's say we're going to assume we got the x squared. No a term that's different. If the vertex were like right here, let's say, and it goes up, and it's our standard x squared kind of thing, you would know that you would need to get 2 to the right. You need to do -2. And then to get 4 down, you'd have to do -4. Like you could write it from a graph.
Oh, okay.
Yeah, you got that skill, even if you don't know you got those skills.
It'd be harder to figure out how wide it is.
Yes, there'd be different. We're gonna learn all these forms, and they're all gonna have different strengths and different uses, right? Okay. Lesson summary. You got to show it to me to get your homework. Let's go.